Hi everyone, this is a flip video about ionic compounds. Ionic compounds are made up of metals and nonmetals. So let's write that down. They're between metals and nonmetals. And if you notice in the word ionic, you see the word ion. So do you remember what an ion is? That's right. An ion is a charged atom. Remember, we have cations and anions. And because you love him so much, I am bringing back Pussycat, who is positive, right? All right, so what happens in an ionic compound is the ions come together to make a new substance. So you have a positive ion coming together with a negative ion because there's an attraction there to make an ionic compound. So let's take a look at some examples. If you remember, metals tend to form into cations, and nonmetals tend to form into anions. So let's take a look at your periodic table and pull some ions out. I'm going to pull out sodium. So sodium as an ion is Na+. A nonmetal that you're familiar with is chlorine. Chlorine as an ion is Cl-. Okay? These two will come together and have an attraction and bond. This type of bond, when it's a cation and an anion, or a metal and a nonmetal, is called ionic compounds or ionic bonding. So when they come together, as you remember from your lab, you only need one Na and one Cl, because one Na has a positive 1 charge and one Cl has a negative 1 charge, and they equal out to be 0. This is the ionic formula. So let's recap about charges again. If you remember in your lab, you did magnesium, 2+, right? And bromine, 1-. Cation, anion. Positive and negative being attracted to each other, ionic bonding, ions. So the goal is to make a neutral formula. A neutral formula, just like you saw in your lab today. Well, I have a 2+ charge here, and I have a 1- charge here. So 2+ and 1-. If I have 2 of these 1-, right, if I add on 2 of these, just like you added on puzzle pieces, I now have a total of -2 there. So if I add 2 of the 1- charges, I get 2- and 2- and 2+, 2- and 2+, make 0 for a neutral compound. That's the goal, a neutral compound. So when I write the formula, I need just one of the Mg's, and how many of the Brs? 2. So I write Br subscript 2. Anytime you make a formula, you're going to use little subscripts. Never big numbers, never coefficients. Let's remember that. Let's try another example. Okay, I need a cation, so I'm going to use aluminum 3+, and I need an anion. I'm going to use kind of a big anion here, SO4 2 minus. You saw that in your lab. That's called sulfate. So aluminum has a charge of 3 plus. Sulfate has a charge of 2 minus. Ionic bonding, because there's ions. Metal bonding with nonmetals. Cation bonding with an anion. Ionic bonding. So let's write this formula. Well, let's see here. 3 plus is my charge here. 2 minus is my charge here. A good way to say is, what is the common denominator? Or what is a common multiple? A common multiple that can get me to neutralize this. Hopefully you said 6. Because if I take 2 of the aluminums, I get 6 plus. And if I take 3 of the sulfates, I get 6 minus. 6 plus and 6 minus give me 0. Neutral compound, no charge left over. So what does that mean? I need 2 of the aluminums. Again, let's draw it out so you can see it. Each aluminum comes with a 3 plus charge. That's a total of 6 plus. See that? Okay. And then how about here? I need 3 of these. 2, 4, 6. For a 6 minus charge. Do you see that? Each one comes with a 2 minus charge. 2 minus, 2 minus. 2, 4, 6. And now the 6 minus to balance out my 6 plus. 6 minus and 6 plus gives me neutral. How do I write this formula? Well, this was a little tricky. So I needed 2 aluminums. Okay? That's easy. Here it is. 2 aluminums. Subscript behind it. And now I need how many of these? 1, 2, 3 of them. 3 of them will balance out my charge. So SO4, how am I going to tell you I need 3 of them? Maybe you remember when we were doing that counting atoms worksheet. Put a big parentheses with a 3 on the outside. 3 of these things right here. Good? Hopefully you understood this. That's the end of the lecture.